Hello students, welcome to Misostudy and welcome to my class. Today we are going to discuss few more questions from the chapter Atomic Structure, Chemical Bonding and Periodic Table. I will try to cover maximum number of questions. Okay, first of all my basic concern will be from the question atomic structure and periodic classification of element. Clear? Now read the question carefully. What is given here? I have taken this question from the topic Heisenberg uncertainty principle, and look at here what is given. The position of both an electron and helium atom is known within 1 nanometer. That is, it is given delta x is equal to 1 nanometer, that is 10 to the power minus 9 meter. Okay, the momentum of the electron is known. The momentum, that is delta p, is given here. Momentum, that is p, the minimum uncertainty in the measurement of the momentum. Okay. It is given here the momentum of the electron is known to be 5 into 10 to the power minus 26 kg meter per second. Clear to you? Yes. The minimum uncertainty in the measurement of the momentum. The minimum uncertainty is this value. Clear? Or you can directly like delta x into delta p is greater and equal to h upon 4 pi. Okay, by writing that is delta p is equal to h upon 4 pi m. Clear? Yes, 4 pi, not m, 4 pi x. Clear to you? Yes, 4 pi del x. That is h is, what is the value of h? 6.626 into 10 to the power minus 34 upon 4 into 3.14 into 10 to the power minus 9. Is it clear? Yes, sir. Now we will solve 6.626 upon 4312, 4416 and 415. And 4 3s are 12, okay, into 10 to the power minus 34 minus 9. Yes, sir. Now it will be value around 1 by 2, around 1 by 2 into 10 to the power minus 34 plus 9. That is 1 by 2, that is into 10 to the power minus 25. Is it clear? That is, what will you get? 0.5 into 10 to the power minus 25. We will get the value 5 into 10 to the power minus 26 kg meter per second. Look at the same data we are getting here. So this is Heisenberg uncertainty principle. Prediction also help you a lot. Otherwise, do all the steps. So for this question, we will say that is B is the correct option. Am I right? Yes, sir, you are absolutely right here. So in atomic structure, these are the main topic you have to focus. What I am telling, that is matter waves, then there come Heisenberg uncertainty principle. Now the second part, that is Schrodinger wave equation. You have to focus on the significance of psi square. Then how to find nodes. Do you have any idea? Nodes? Yes, sir, nodes where the probability of finding an electron reduced to 0 or 0 is called nodes. And there are two type of node we know, that is radial nodes and angular node. Radial and angular. Radial node is also known as spherical node. What is the number of radial nodes? That is, maximum number of questions are number of radial nodes, that will be equal to n minus l minus 1. And what are the number of angular nodes? Angular nodes, that will be equal to l. Again I am repeating, number of radial nodes is equal to n minus l minus 1, and number of angular node, that will be equal to l. And the total number of nodes, that will be equal to n minus 1. What are the antinodes? Where the probability of finding an electron is maximum is called antinodes. Clear? What is the psi square? That is, it shows the probability of finding an electron, that is where the electron can be found easily, that is it shows about the atomic orbitals. Clear to you? That is, first electron resides in orbit, then their suborbit or subcell or cell, then there comes orbital. Clear? Suppose, do you have the idea? Yes sir. Orbit can be represented like K, L, M, N, O, so on. Suborbit S, P, D, F, G, so on. And orbital in a box. And each orbital contains 2 electrons in different mode, that is different spin. One is parallel, the second one is anti-parallel. Clear? Suppose if I write here K, K has, we know, 2 electron, it has only one subcell, and for K the value of n is equal to 1. If the value of n is equal to 1, the number of subcell will be 1. Now Ks has 2 electron and it has only one orbital. Clear? Now if I write here L, L has, we know, 8 electron, that is in this case the value of n is equal to 2, and if the value of n is equal to 2, definitely it will contain 2 subcell, that is S and P. S contain 2 electron and P contains 6 electron. 6 plus 2, overall 8 electron. Now each orbital contains only 2 electron, so S will have only one orbital, and P has 6 electrons, so it will have 3 orbital like this. Clear? It is represented like this: Px, Py and Pz. This is the naming. Yes. Now like this, if this is a nucleus, this is K, this is L, this is M, this is N, this is O, and so on. First, due to this reason, n is equal to 1 second, n is equal to 2 third, n is equal to 3 fourth, n is equal to 4, and fifth, n is equal to 5. So in M, we know there are 18 electrons. We know the formula: number of electron in a cell is equal to 2n square. For M, the value of n is 3. 3 into 3, 9, 9 to the 18. M has 18 electron, and we know for this the n is equal to 3. So it will have 3 subcell: S, P and D. Is it clear? Yes. S has 1 orbital, P has 3 orbital because P has maximum 6 electron, and D has 10 orbital. So D will have, D has 10 electron, so it will have 5 orbitals: 1, 2, 3, 4, 5. Clear? Yes. One orbital contain only 2 electron. It is Px, Py and Pz. It is dx square minus y square dz square. Dz square has no node. Clear to you? Yes. Then dxy, dyz and dxz. Clear? Similarly, if I write here n, number of electron here 32. Clear? And the value of small n here is 4. So it will have 4 subcell: S, P, D and F. Clear, my friend? Yes. S has, we know, a spherical shape. P has dumbbell. D has double dumbbell. And F has complex shape. It is slight out of your syllabus. You have to just focus on S, P and D. S can be written like this. This is a cloud diagram because electron has wave nature also. This is S and this is P. Like this P, like this P, different direction, that is X, Y and Z. This is P. Okay, and for D, we know the dz square like this. All are equal. This is dz square. Okay, or it can also be written like this. This is and this is the terming around dz square. It has no node. For example, dx square y square, it can be written like this. like this, like this, like this. Clear? Yes. Then again we can write this is dxy, dyz, dxz. Clear, my friend? This is these are the shapes. F has complex cells. I cannot draw here the complete structure like this also, like this plane also, dxy, dyz and dz. Clear to you? Yes. So n, what is n? The value of n, that is orbit. What is the value of L? Look at L, that is azimuthal quantum number. For S, L is equal to 0. The value of L is 0. For P, the value of L is 1. For D, the value of L is 2. And for F, the value of L is 3. Clear? Yes. So if anyone asks you what are the number of nodes in 3s, number of radial nodes. So we know the formula, number of radial nodes is equal to n minus L minus 1, 3 minus 0 minus 1. Number of nodes equal to 2, radial node. What are the angular nodes? Number of angular nodes, that will be equal to L. L is equal to 0 because for S, L is equal to 0. What are the total number of nodes? Total number of nodes equal to n minus 1, that is 3 minus 0, that will be equal to 3. Is it clear? Yes, this is the case. So it is important point. You have to focus on it, that is nodes, that is radial and angular nodes. Now I am moving here to discuss the next one. The next one we are going to discuss, that is quantum number. Again, they pick this topic, quantum number. We know to get the complete information, we have the set of 4 numbers are called quantum number. That is, first one is n, that is principal quantum number. Do you remember this? Yes, that is principal quantum number. Yes, that is NL. This is azimuthal quantum number. Yeah, yes sir. The NLM, this is magnetic quantum number. Yes, and the fourth one what we have, that is spin quantum number. We have 4 set of number N, L, M or S: principal, azimuthal, magnetic and spin quantum number. These 3 quantum number can easily be governed by Schrodinger wave equation, but this quantum number, Schrodinger wave equation cannot explain this quantum number, spin quantum number. Clear to you? Yes. Now if anyone asks you how to find the angular momentum, spin orbital angular momentum, that is the formula is equal to root under L, L plus 1. L is the number, L azimuthal quantum number. The value of L is, we know for S equal to 0, for P that is equal to 1, for D that is equal to 2, and for F that is equal to 3. Am I right? Yes sir. So focus on this, that is quantum number. Then I have discussed orbital, Schrodinger wave equation, that is significance of psi. Then the graph also, graph you have to focus on, graph between psi and r, or psi square and r, like this graph. For 1s we know this type of graph we are getting, no nodes. Similarly for 2s, for 3s we can draw the graph by using the formula here, not. Then the simple theories, Hund's law of maximum multiplicity, Simon's rule, n plus L rule, filling above principle, I think sufficient for you. You can easily solve the question if you have a command over this topic. Clear my friend? Yes sir, you are absolutely right here. Now let's move to the next question. What is the next question? Check the thing. I'm going to rub this part. Clear? Yes sir. Wait for a moment. Let me check the angle of the questions. Now, given here, according to the Bohr theory, En is equal to total energy, Kn is equal to kinetic energy, and Vn is equal to potential energy, and Rn is radius. Clear? Yeah, this is Rn. This is R, okay. Now it is given here column 1 Vn upon Kn. Kn is kinetic energy. So what will happen in this case? We know the formula of Vn, that is we can write like this, 1 by 4 pi epsilon naught Ze square upon Rn. Can I write? Yes sir. Then Kn is equal to, we know, 1 by 8 pi epsilon naught Ze square upon Rn. Yes sir, definitely we can write. Okay, then what will be the difference here given? Vn upon Kn is equal to 1 by 4 pi epsilon naught Ze square upon Rn upon minus 1 upon 8 pi epsilon naught into Ze square upon Rn. Is it clear to you? Yes. Now what will happen? This will cancel this one, this will cancel this one, and 4 to the 8. So Vn upon Kn, that will be equal to minus 2. Am I right here? Check the thing. Vn upon Rn is equal to minus 2. Is it clear? Now the next one is, if the radius of the nth orbit, is directly proportional to e to the power x. This is slightly different. That is e to the power x, radius of the nth orbit, Rn. Okay. This is some difficulty in the topic. En, radius of the nth orbit, what is En, is directly proportional to the x. What is x here? Okay. Radius of the nth orbit, that is Rn. Rn is equal to, we know, that is R naught into n square upon z. Clear? What I am telling, Rn is equal to R naught. Radius of the nth orbit is directly proportional to the e. That is given here. Rn is directly proportional to the En to the power x. This is given here. Okay. And for first, we know the option we have got minus 2. Okay. That is, we know En is equal to minus E naught Z square upon n square, like this. And I think there is a missing in the question. If the radius of the nth orbit is directly proportional to the z to the power y, that like written like this, then it will be equal to minus 1. And energy is equal to, there is some mistake in the question. If the radius of the nth orbit, it cannot be written like this. Radius of the nth orbit is equal to Rn is equal to R naught n square upon z, and for En is equal to z square upon n square. We know how Rn in En possible. If I write here z into n is similar, that is only there is a gap of z. So if Rn is directly proportional, if I take this value as a constant, then still Rn is directly proportional to n square upon z, and En is directly proportional to z square upon n square. Okay, this is a slight different thing. I think we have to check the probability. Give me a few seconds so that I can check this question. So I hope the sense of this question, let me check. I have checked it. If the radius of the nth orbit, okay, actually we do not apply here like this. That is, we know simple formula. Look at that is energy En in terms of, we will write here 1 upon 8 pi epsilon naught then Ze square upon Rn. Clear? Yes. So what is the relation here? En is directly proportional to 1 upon Rn, like this. That is En. So we will write here that is En, Rn is inversely proportional to En, or you can write Rn is directly proportional to En to the power minus 1. This is the case. That is the sense. Okay. Clear? Okay. Now I am going to rub this part here like this. Rn is equal to 1 upon En, that is En to the power minus 1. So here x, this is x according to the question. So x will be equal to minus 1. So for B option we will write Q is the correct option, and for A option R is the correct option. Is it clear? Now angular momentum of the lowest orbital. Lowest orbital is 1s. For 1s, the value of L is equal to 0. Angular momentum formula L plus 1, that is 0 plus 1, that will be equal to 0. So for this question P is the correct option. Now we have the rest one, that is S. R. We know Rn is equal to R naught n square upon Z. Clear to you? That is, we can write here that is Rn is directly proportional to 1 upon Z, or we can say that is 1 upon Rn is equal to Z. Clear? 1 upon Rn equal to Z, that Z is equal to Zy, here y is equal to 1 power, that is Zy, Z is equal to 1. So S is the correct option. Clear? Yes sir. Can I rub this part? Yes sir, you can absolutely. Now let's move to the next question. Now let's move to question number 6. Now this is a statement type question. Read the assertion reason. If each of the following question, a statement of assertion A is given followed by a corresponding statement of reason R, make the correct answer. If both assertion and reason are true and the reason is correct explanation of assertion, if both assertion and reason are true but the reason is not a correct explanation of the assertion, if assertion is true but the reason is false, if assertion and reason are false. Now read the question here. Statement: in the titration of Na2CO3 with HCl using methyl orange indicator, the volume required at the equivalent point is twice that of the acid required using phenolphthalein indicator. Here the statement 1 is factually correct, not completely wrong, not completely true. Okay. Statement 2, 2 moles of HCl are required for the complete neutralization of 1 mole of Na2CO3. 2 mole, that means to say what? There is no complete link up. So we can say here, if I write here, that is assertion is somewhat true but the reason is false. Again I am repeating, the assertion is true but the reason is false here. So better to put that is C is the correct option. Now let's move to the next one. Next one, the quantized energy of an electron is largely determined by its principal number, and reason the principal quantum number n is the measure of the most probable distance of finding the electron around the nucleus. Read. I cannot solve this question. I will not solve this question. You have to solve this question. This is simple logical question, completely theoretical part. You have to reply. That is, the quantized energy of an electron is largely determined by its principal quantum. Quantized energy largely determined by its principal quantum number, and the principal quantum number n is a measure of the most probable distance of finding the electron around the nucleus. Now these two reasons you have. Now by using this chart you have to apply the answer, you have to reply the question. I am leaving this question only for you, and I think you can easily solve. Now let's move to the next part, that is the question. the first ionization enthalpy. I have taken this question from the chapter periodic classification of elements. Now what is given here? The first ionization enthalpy of Na, Mg and Si. Clear? Again I am repeating, the first ionization in enthalpy of NaMg. What is the mean by ionization energy? We know the minimum energy required to remove the electron from the outermost shell is called ionization energy. So ionization energy of NaMg are given. For Na, that is 496 kilojoule per mole. For magnesium, that is equal to 737 kilojoule per mole. And for silicon, that is 779 kilojoule per mole. We have the data. Now they are asking what will be the first ionization enthalpy of aluminium. Now which concept we are going to apply? Look at, as we know, if I write here Na, Mg, Al, Si, phosphorus and so on, I am taking the for example. As we know, when we move along the period, ionization energy increases. Ionization energy increases. Clear? Because the non-metallic character also increases, the value of effective nuclear charge also increases, so it is not easy to remove the electron. And down the group, we know ionization energy decreases, because the size increases, so you can easily remove the electron from the outermost shell. It will require less amount of energy. Now there is a condition. If there is a half filled or full-filled subcell, fulfilled configuration, that are stable configuration. What I am telling, they have stable configuration. In this case, that is, they require maximum energy to remove the electron. We require maximum energy to remove the electron from the outermost shell. So here if we compare that Na, Mg, Al, Mg has electronic configuration NS2 NP2 type, and Al has electronic configuration NS2 NP3 type. Am I right, sir? You are wrong. Mg has electronic configuration NS2, Na has electronic configuration NS1, and here is NS2 NP1, and silicon has NS2 NP2. We can write here that is 3S1, here we will write 3S2, aluminum we will write 3S2 3P1, and silicon we will write 3S2 3P2. Is it clear? Now this is a stable configuration, so the order is sodium, then aluminum, then magnesium, then silicon. This is the order. Yes. Now aluminum should have the ionization potential between Na and Mg. Na has value 496 and Mg has value 737. So greater than 496 and less than 737. What is the answer? Greater than 496 and less than 737. This is the correct answer. B is the correct explanation. Is it clear? Yes, sir, completely. Now let's move to the next question, question number 10. It is given here, which of the following option with respect to increasing bond order. Before starting this question, this is a question for chemical bonding, I have to discuss few topics from periodic table, then we'll move here. Periodic table. We know in periodic table it's very easy to find the group and to find the period. Do you have any idea? Yes, sir. If anyone asks you what is the group number and period of silicon, write down the expression, that is we will write here 1s2, 2s2, 2p6, 3s2 and 3p2. This is the normal method. You can also apply the cell-wise electronic configuration. 284, clear, that is K, this is L and this is M. We can say for M, N is equal to 3. So in this case silicon has period 3 and outermost shell 4 electron, so group will be equal to 14. It's very simple. And look at here, the last electron in P, by using this subcell wise last electron P in this case, for P we add 2 to 4 and add 10, that is the 14. This is the rule. And what is the period here? What is the highest value? That is 3. So this is the period. And this is a P block element. So this is the rule. If the last electron enter in the P subcell, then add. To finding the group number, add 10. I am taking another example. Na, N 7, 1s2, 2s2, 2p3. Last electron enter in the P subcell. So in this case, this is a P block element. Period, what is the largest value here? 2. What is the group here? We know group for S, for P, add both outermost S and P electron. 3 plus 2, 5, 5 plus 10, that will be equal to 15. Clear to you? That's why we write always NS and P for P block element. Clear to you? NS2 and NP 1 to 6. Now if anyone asks you to find the D block element, it can be written like this: 1s2, 2s2, 2p6, 3s2, 3p6, 4s2 and 3d1. In this case, what is the period and what is the group? Tell me. That is D block element group, last D and S electron 3, not at 10. Period, what is the highest value? 3 or 4? 4. So period 4 and group 3. This is a simple technique to find the group and period. Now the properties. That is, first of all, you have to find out atomic size. That is, you can write atomic radius. We know that is, first we have ionic radius. For cation we have cationic radius. Cation are smaller than anion always. Cations are smaller than anions. In case of isoelectronic species, very easy to compare. Cations are always smaller than their respective neutral atom. Anions are always larger than their respective neutral atom. Then covalent radius. Second one is covalent radius. The third one is metallic radius. Yes, third one is metallic. Covalent radius, metallic radius. Then van der Waals radius. Van der Waals radius. These are the important type of radius. For inert gases, we consider van der Waals radius. Clear to you? For metals, we consider metallic radius, and for non-metals, we consider covalent radius. Van der Waals radius is always greater than the covalent radius. Clear? Then properties, ionization energy. Clear to you? Yes, ionization energy, we know the minimum energy required to remove the electron from the outermost shell. Okay. Then focus on electron gain enthalpy. Electron gain enthalpy or electron affinity. This is the case for non-metals. It is a endothermic process. Energy required, it is endothermic as well as exothermic. Here delta H may be positive or may be negative depending upon the situation. Then the next, that is MP, melting point and boiling point variation. Then the Sheldon effect or screening effect. Screening effect or Sheldon effect, that is Slater rule. Slater's rule, you have to follow Slater rules and you can find the value of effective nuclear charge. Z effective will be equal to Z minus screening constant. This is the formula. Z effective is equal to Z minus screening constant. Am I right? Yes sir, you are absolutely right. Then focus on electronegativity. Electronegativity also. For this Mulliken scale, already Rassau scale, do you remember this? Yes sir. So find the value, solve the numerical part also, then and then only you can easily tackle the periodic table. If you have a command over the periodic table, then you can completely solve the questions of inorganic chemistry. Is it clear my friend? Yes sir, you are absolutely right here. No need to explain further, simple one. So in periodic table, atomic structure, atomic size, types of atomic size, ionization energy, electron gain enthalpy, electron negativity, then melting and boiling point, density of each variation of density in each and every group or period. Clear? Yes sir. Now I am not going to add more question. Chemical bonding, the question of chemical bonding or question of state of matter I will solve in next lecture. I think you are now familiar with this topic and definitely it will help you a lot. Practice the question, practice the maximum number of questions and you can achieve your destination. So my friend, time has come, time to say bye bye. Thank you so much.